The James Webb Space Telescope made an unexpected find that showed what appeared to be city lights in space, 7 trillion miles away from Earth. This exceptional finding has ignited interest in the chance of extraterrestrial life. The telescope zeroed in on Proxima Centauri b, the nearest exoplanet to Earth, uncovering surprising splendid lights exuding from it. On Proxima Centauri b, why do these city lights appear? Could this be a sign that life exists beyond our planet? Come along with us as we investigate how these extraordinary space objects were discovered by the James Webb Space Telescope. Humans and scientists alike have been searching for signs of life beyond our solar system for years. Any evidence that appears to support this space fantasy has been warmly received. The James Webb Space Telescope's discovery of convincing evidence of life in space recently caused the scientific community the shock of their lives. While exploring space and detailing fundamental data back to Earth, the telescope saw peculiar city lights sparkling from the exoplanet Proxima Centauri b. The name of these lights suggested that they were illuminating a faraway city. The chance of an outsider city existing on this star has left researchers bringing in wonder. They are confounded in light of the fact that this could be the proof they've all been hanging tight for. Assuming that this ends up being valid, as many accept it may, it actually intends that there are smart living things sorting out civic establishments unfamiliar to what people know in space, and we are just barely finding it. Looking into these city lights that are found 7 trillion miles from Earth, NASA engineers can't resist the urge to consider how long these lights have been sparkling in space, trusting that people will foster the innovation expected to recognize them. Columbia University astronomer David Kipping describes the Proxima Centauri b exoplanet where the city lights were discovered as challenging. He said so on the grounds that this star framework closest to us has shifted warming examples that aren't like those of different planets. This exoplanet's infrared nature is quite distinct from that of its host star, Proxima Centauri. While typical rocky planets are known to absorb sunlight and produce infrared radiation, it is not the case for this exoplanet. This mentions for a decent observable fact by the James Webb Space Telescope, which is capable at recognizing infrared frequencies. Thanks to the JWST's cutting-edge infrared imaging capabilities, the unique heat signature of Proxima Centauri b will play a significant role in determining the universal secrets of its atmosphere. The telescope will be used by scientists to unravel the mysteries of this planet's atmospheric components. Additionally, they intend to evaluate the possibility of residing on this exoplanet with the help of the Webb telescope. Proxima Centauri b's nighttime side can be studied using the James Webb Telescope's infrared sensitivity. Getting the slightest beams of light in the grandiose haziness is generally a battle for space telescopes, yet not for the JWST, as it can recognize even the smallest beams of light from space. It is the ideal instrument for determining whether or not Proxima's night side has city lights. Each fake brightening in the universe can be detected by the telescope as long as it falls inside a recurrence band that is multiple times smaller than the starlight. Proxima Centauri b has a fascinating connection between its heavenly elements and surface communications.
Liftoff of the
Numerous
Delta
solar
rocket
panels harness
carrying
the star's
GLAST,
bubbling
a
radiant
gamma-ray
energy on the
telescope
day side
searching
of the
for
exoplanet.
unseen physics in the stars
Incoming
of the
light
galaxy.
rays are also reflected by its spectra edge. At the same time, when Proxima Centauri b completes its orbit around its host star, Proxima Centauri, it experiences daytime and nighttime temperatures that are comparable to those on Earth. The daytime has high solar heat, while the nighttime has cool temperatures. The planet is known to have still up in the air by its creation. For instance, assuming that there's no air on Proxima Centauri b, the distinction between its day-in and day-out periods will be wide and outrageous. Without the directing impact of climatic gases, the temperature on the day side will be very hot, and the night side will drop into cold murkiness. The level of temperature variety is a critical subject for cosmologists to disentangle a more profound comprehension of Proxima's environmental synthesis. The JWST is able to efficiently examine the planet's thermal emissions and provide insightful information about its atmospheric properties thanks to its unparalleled infrared imaging capability. Interestingly, the James Webb Telescope's orbit around the Earth coincides with the orbital period of Proxima Centauri b, making it possible to observe the star's day and night cycles in detail within 11.2 Earth days. Since Proxima Centauri b does in fact have an atmosphere, the next step will be to examine the chemistry of that atmosphere to see if it can support life. Key signs of life incorporate the presence of gases like oxygen, water fume, and methane. It would indicate that the planet is habitable if these elements are present. Scientists must carefully capture and examine light rays moving through the planet's atmosphere in order to successfully determine this. This is an extremely provoking errand to embrace, even with the JWST's incredible capacities for portraying planetary environments. Despite its power, the James Webb Space Telescope can only observe a small number of the planets closest to Earth that are habitable in order to conduct thorough atmospheric studies. Currently, ground-based observatories like the Extremely Large Telescope, ELT, which are scheduled to begin operation in 2028, are being considered by astronomers. The ELT is situated to look further into the climatic design of distant exoplanets and will create information that offers extensive and clear bits of knowledge into their degree of tenability. NASA researchers and people in general enthusiastically anticipate the organization of future space telescopes like these. Up to that point, the James Webb Space Telescope stays an essential device in our mission to uncover the secrets of far-off exoplanets. Indeed, even with its ongoing limits, the Webb telescope can possibly offer profound experiences that could reform how we might interpret exoplanetary investigation. Researchers have a target for future space telescopes, to lessen how much brilliant light coming from a planet's host star so cosmologists can more readily see the light reflected from the actual planet. They intend to accomplish this by employing enormous umbrella-shaped external satellites or internal masks. Future telescopes will be able to study faint reflections of light from a distant exoplanet, allowing for vivid analysis of its atmosphere and likelihood of supporting life, just as you would use your hand to block out the sun's rays to see an object better. However, there are difficulties associated with this. Geological processes like volcanic activity and gases produced by life will need to be distinguished by scientists. Stargazers are not abandoning understanding the attributes of exoplanets to more readily recognize indications of something going on under the surface and recognize them from misleading upsides. The Webb telescope provides a sneak peek at the amazing discoveries we have yet to make by providing a preview of the scientific advancements resulting from the study of exoplanets. As we stretch our comprehension and investigation of the universe increasingly far, we are better situated to figure out the complicated functions of the universe and our different jobs in it. Subsequent to looking through every one of the planets in space, researchers presently can't seem to find one that has life, notwithstanding many years of scanning through space for indications of something going on under the surface. The journey proceeds. Is it true or not that we are distant from everyone else in the universe? People from all human civilizations have pondered the possibility that they are the only ones in the universe for millions of years. This longing from ages past is still present today. Indeed, even now, researchers have the James Webb Telescope in space, attempting to recognize outsider civic establishments concealed among us while concentrating on a wide range of planetary bodies for indications of something going on under the surface. Simultaneously, a well-known story has arisen as of late, recommending that a few outsiders could genuinely be out there in the stars, only trusting that people will track down them. In 1984, two American astronomers named Jill Tarter and Thomas Pearson started a project called the Search for Extraterrestrial Intelligence, SETI, to find an answer to this question. It is a non-profit organization that plans to search through cosmic signals for radio signals from space. It is called the SETI Institute. Radio signals are the focus because they can travel great distances without being scattered or absorbed like other types of radiation. Because of this trademark, radio transmissions are bound to be recognized by the 42 radio telescopes that comprise the Allen Telescope exhibit, tracked down in the outpouring piles of California. For more than 3 decades, there have been no such radio signals, despite the SETI Institute's fervently observed evidence of alien life. Jill Tarter remaining parts energetic about their possibilities of a positive outcome, communicating a longing to engage Earthlings wherever to become dynamic members in a definitive quest for grandiose friendship. All of this carried on until recent NASA reports suggested that the James Webb Space Telescope had observed city lights from a planet close to Earth. Humans use the JWST as a giant trump card to gain a limited understanding of the galactic mysteries in space. Conveyed in December 2021, it is known as the best infrared imaging telescope at any point made by mankind. Furnished with the most developed optical innovation accessible today, the James Webb Space Telescope can look past the cover of infinite residue to uncover the secrets of the universe. Its essential assignment is to dive into the universe, looking for the absolute first cosmic systems and stars that were shaped billions of years prior. The telescope is planned with probably the most progressive optical innovation in this present reality, motivated by James E. Webb, a visionary administrator at NASA who was a major advocate for the Apollo moon landing and space exploration programs. At its center, the James Webb Space Telescope is made with an exceptional arrangement of instruments, all cooperating to give unrivaled perspectives on the universe. A mid-infrared instrument, a near-infrared camera, a near-infrared spectrograph, and a fine guidance sensor enable it to keep its precise position in space. The Goliath reflection of the James Webb Space Telescope, comprising of 18 hexagonal fragments, has been fastidiously created to catch faint light from the furthest reaches of the universe. Astronomers now have unprecedented clarity when looking at distant galaxies and planets thanks to the stunning image of space created as a result. It can also get through the thick clouds of gas and dust that usually make it hard to see into the universe. Now that the James Webb Space Telescope has spotted indications of what is by all accounts outsider development, how much longer until we know the response to this deep-rooted question? Would we say we are separated from everyone else in the universe?